Now we have the quotient rule. We learned in the previous video how to deal with it when two functions are being multiplied. Now we're going to know how to deal with it when two functions are being divided. So when we have one function divided by another function, the derivative is f prime times g minus f times g prime all over g squared. Now if you notice, the top of this is identical to the product rule except for the minus. The product rule has plus in between. But if you have the product rule memorized, then the quotient rule is pretty simple. You just change the plus to a minus and divide by g squared. So on this very first example, notice we have to call f the top and we have to call g the bottom. In the product rule, it really doesn't make a difference because it doesn't matter what order you multiply in. But with the quotient rule, it does. It's super important that you call the top f and the bottom g. So I'm going to follow the same pattern though and write my f of x and my g of x over to the side because I need the same pieces as before, f and g and their derivatives. So f prime will be 5, g prime will be 2x. Then we do f prime times g, so that's 5 times x squared plus 1 minus f times g prime, so I get 5x minus 2 times 2x. And then I divide that whole thing by g squared. Now I don't want to touch the bottom, leave the bottom just the way it is, but I do want to simplify the numerator at the top. So I'll distribute the 5 first, 5x squared plus 5. And then I'm going to go ahead and distribute this 2x in and this negative at the same time. So I'll get negative 10x squared plus 4x. And that'll be all over x squared plus 1 squared. So my final answer, if I just combine my two like terms here, will be negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Just have one more example with the quotient rule, and this one has trig. Again, you have to call the top f and the bottom g, so we'll make f of x equal to 1 minus cosine x, and g of x equal to sine x. F prime is, well, the derivative of 1 is 0. The derivative of cosine is negative sine, so that cancels out the two negatives, and you just get sine of x. And g prime, the derivative of sine x, is cosine x. I do f prime times g, sine of x, times sine of x, minus f times g prime, all divided by sine squared x. So if I start simplifying the top, sine times sine is sine squared, and then I distribute the cosine x in, divide the whole thing by sine squared x. Then on top I'll go ahead and distribute the negative through, so sine squared x minus cosine x plus cosine squared x, all divided by sine squared x. Now if you notice, if you're really clever, there's a trig identity here. Sine squared x plus cosine squared x is equal to 1. So I can change both of those pieces to just equal 1, and I'll just be left with 1 minus cosine x, all divided by sine squared x. And that would be my final answer.